Hey there, this is Seth Schaefer from Team Just Cause Robotics, and in today's video we are going to go over the full construction of an SSP kit from start to finish, except for the electronics sections which were already covered in previous videos. So you should basically be starting out at this point with soldered motherboard, Terracan, soldered to your motors, etc. But everything else is completely disassembled. Now I have here two assembled fork setups just because I wanted to save a little bit of time here. This is probably the most straightforward possible thing ever. You just put nuts on one fork mount and screws through the other, sandwiching the fork in the middle. So this is what the standard fork setup looks like, and it just dovetails into the chassis like so. So for the sake of the video, I'm going to show how to put together the hinged fork setup, since that one requires at least 5 more brain cells than this. So you should receive with your kit this handy dandy screw organizer which contains everything you need. First thing that we're going to do is deal with the wheels. So you've got 2 bushings, you've got your front wheels here. We're just going to shove a bushing through there all the way and then have it protrude a little bit out the back, maybe about 1 millimeter or so. Next, we repeat with the other wheel. Same exact thing as before. Whoops, that's the wrong kind of wheel. Just push it in, push that out a tiny bit so it sticks out a little bit. Those wheels are now set to go. Next, we've got the hex hubs. So for this, you're going to need your 2mm hex wrench, which is included in the kit, and your M4 set screws, these little black guys here. So these set screws will be going into the hubs, and I would recommend that if you're doing this for real that you use blue Loctite to secure these. I am going to have to take this kit apart so I can put it in a box and mail it to somebody afterwards, so I'm not going to do that because that would make it difficult to disassemble. But in general, I would recommend that you use blue Loctite, such as, well, of course this bottle is covered, but Loctite 242 or 243. It's sold in much smaller containers than this, such as a size like that, or even tiny little tubes for pretty cheap, like less than $10 for a thing that'll last you for dozens and dozens of screws. So, start off with, we're going to take a set screw, put it on our hex key, we would dip it into some blue Loctite, and then you want to put it into the flat side, not the rounded side, the flat side of your hex hub here, until it is just under the surface. And we're going to repeat that times 4. Do a bit of a closer close-up here. Just below the surface, next to here. Perfect. Next, you've got a hexagon on this side, round on this side. So hexagon side is bigger. You need to line up the holes. So there's a hole there, and I'm just gonna push that in until it doesn't go anymore, and then you should have a perfectly lined up set screw with a hole on both sides. Repeat on this side. Line up your holes with your holes, push it in until it doesn't go anymore, boom. And you should see it's not quite all the way at the end, that's intentional, and that is that. Next, we are going to stick our driver in, and whoops, wrong ones. Stick our driver in and loosen the set screw just a bit to make sure that our motor shaft can fit through it. Perfect. Now, both of these wheels are identical, but you'll notice that the motor shaft has a flat on one side, so we are going to line it up so that one of the holes is directly over that flat, and Just gonna put it snug for now. We'll probably loosen this and adjust it again in a little bit. Put that back for the moment. Same on the other side. Make sure that your tire is to the outside and you've got one set screw over the flat. Tighten the set screw on the flat first so that it reorients itself. Then the one not facing the flat, just so it's a little bit snug for now. Those are obviously not fully secured yet. We will worry about that in a little bit. Although I just realized I forgot to grab the motor clamps, so let me run and grab those. Going to be needing those later on. Oh right, I forgot, I was gonna do the forks. So we got the wheels prepped. Let's do the hinged forks, why don't we? For that, I of course need the hinged forks themselves. Now, the only vaguely tricky part about this is that these need to be oriented correctly, so the dovetails are towards the top side. The fork is going to be lined up with the top hole. So I'm gonna move my shoulder bolts to over here so I have access to the M5 bolts. You may get silver ones like this, or you may get black ones, because I just ordered a bunch that ended up being black. So screw head comes in the side that doesn't have a hex imprint on it. And then we just grab one of our M5 hex nuts, shove it in here. Then we grab the included 4mm hex wrench, and we're going to tighten this a little bit, but not too much. Actually, what you should do is basically tighten it a lot, just so that the hex nut gets pulled in, then loosen enough that the fork can freely hinge. And then you can stick that guy right into the front of the chassis. Repeat with the next one. So we're going to grab a bolt, stick it through, hex nut, shove that in, through, tighten a lot at first to pull the nut in as far as it goes, then loosen until the fork can freely hinge. Then dovetail it into the chassis, and you should be able to basically do that. If you want to tighten it a little bit more after that, you can. Just make sure it still freely drops. Perfect. So that's that. I'm going to flip this around so you can see the wheel setup better, because we're going to need that in a bit. I'd like to take a short moment to thank longtime channel sponsor PCBWAY. PCBWAY has been a supporter of Team Just Cause Robotics for more than an entire year now. They have offered CNC machining and PCB fabrication for a number of the projects that I've displayed on this channel, and they continue to do so while I have a new version of the motherboard being produced by them right now. You can make sure to get awesome discounts on CNC machining, flexible PCBs, and more. They currently have a promotion for $30 off PCB assembly, which I'm using with those motherboards as I just mentioned, and you can see they also offer a 3D printing service that you can check out as well. So make sure to take a look at PCBWAY for all of your fabrication needs. Next, let's set up the wheels, front wheels. So the reason that we didn't secure the motors down yet is because we need to do the belts, and it's easiest to do this with this a bit loose. So we are going to shove a belt over here, stick that wheel there, and just leave it for now. Belt over here. Stick this wheel in. Just leave it for now. So the motors are not slotted in yet, so that we can actually have some freedom to move around the front wheel here. Now what we're going to do is we're going to grab 2 shoulder bolts and this part's a little bit tricky. What do is stick the bolt just a bit through till it just gets lined up with the bushing in the wheel hub, and then it kind of goes through, and now you might need to jiggle it a tiny bit to get it to go all the way in. Or if you get your T15 Torx driver in there, it can help to kind of angle it a bit. There we go. So now that's all the way through. Now we will just rinse and repeat on the other side. Kind of get it just a bit. Then stick it all the way through. That one went perfectly first try. Now we can slot the drive motors into place and make sure that the belt doesn't catch any of your cables and whatnot. Now, there's going to be some different manufacturing tolerances with every chassis. At this point you may see that the belt's like super loose and it might even skip a little bit when you do this. That's fine. It will be because the chassis is ever so slightly warped, and once you put the lid on it'll stiffen everything up and it'll be really nice. In this case it seems like it's fine just now. I think that having the tighter motor slots in this chassis versus the ones I was using at Norwalk helped in that regard. Unplug this so that the motherboard's kind of out of my way here. Next, we are going to grab needle nose pliers and our little Nylock M3 nuts and our T15 Torx driver, and we are going to get our pliers vertical and our driver aligned with that shoulder bolt drive axle. Hold the nut like so, kind of firmly, and we should be able to tighten that. I've got a ratcheting screwdriver that really helps here. And we're just going to keep going until basically we can't turn it anymore. Alright, and now we should still have a nice free spinning wheel with a tiny bit of play. Repeat on the other side, exactly the same. Now grab the nut firmly by the flats. Go until we can't turn it anymore. This would be much better if I was holding the screwdriver with my right hand, but whatever. Perfect. Now you'll note we did not fully snug up on these wheels before, these back ones. So for that, we can grab our hex driver, turn this guy until we can actually get the wrench in place, and then you can just snug up on those, set screws, turn it 180 degrees, and repeat. Same on this side. Turn 180 and repeat. Perfect. And now you should have some nice, perfectly tracking, tightened, belted wheels. Awesome. we have what looks kind of like a robot now. Let's go ahead while we are in here and install the motherboard. So for that, you're going to need these button head number 6 1/4" screws. Just gonna get one on here. I'll start with this corner of the motherboard, get it lined up with the nice little hole in the chassis, and screw should just thread in there. And you just want to put this nice and snug. It should not be over tightened. You will strip out the threads in the chassis if you try to over tighten. Do that again here. And one more time. There's one extra screw in case you drop one of these. Third corner right down there. Motherboard's now nice and secure. Alrighty. We'll go back to wiring this up so we can stick the Terracam power wire wherever. And then these black outside. This is channel 1, so that's the first. This is channel 2, so that's the second. Black wires facing that way, and we're just going to those first 2 channels without the center pin. Make sure your black and white are on the 2 pins that are present, just like so. And now you've wired up your drive system for success there. Perfect. Next, we have to contend with the servo and servo arm. So let's do that. I'm going to show building up both arms, even though you probably only need to build up one at a time here. So let's start with the standard arm. So you're going to need 2 of these guys. You're going to need 3 shoulder bolts. And we're going to need these press insert nuts in this pocket here. So to start out with, I'm just going to stick 3 shoulder bolts through one of the metal forks. Next, I'm going to align those 3 here. Just going to push, might be a hard push, until those get all the way through. Next, stick that guy on there. And the nuts kind of go inside the holes, so you'll notice the thread kind of goes to the edge there. That's okay, because the nut goes inside of the hole. So when we tighten it, it kind of pulls the whole arm together a bit. You should see the thread kind of sticking out a bit there. We'll repeat with the front one. There we go. That one wasn't sitting flat at first. Tighten it about the same so that ends up nice and parallel. And then, of course, the middle. Next, we're going to need our trusty 2mm hex driver again. We're going to be inserting a flathead screw through here to secure the steel servo arm. So let's get that steel arm out, why don't we? You don't need any of these. You do need this. So this is the steel servo horn, servo arm, whatever you want to call it. And this guy, it only fits in one way. It's pretty obvious. It goes in like this. Might be a bit of a tight fit, but you should be able to squeeze it in. Next, you're going to take one of your M3 flatheads and just drop it in there. You're going to have to push it down while you turn a little bit. This, kind of push it a little bit, and you should eventually start to turn it and see that the thread is rising up into the steel arm. And just stop when it's right about flush, like that. That's pretty good. And the steel arm, you should be able to press in a little more so it sits just shy of that whole surface. Perfect. Next up, we've got the servo itself. Goes in like so. And the cable, it's a little bit of a tight fit, but black wire again towards the edge, and you should kind of get it such that it's right up against the channel in front of it. So you should be plugging into channel 3, not to the one on the outside, channel 4, channel 3 specifically. Just like that. We aren't going to put the little plate to hold that in place just yet because we need to align this. So let's get our battery so we can do that. Probably have one over here. So next we will plug in our battery. This one might be switched on. Yeah, so normally you would want the motherboard to be switched off when you're doing this. So you just stick your wrench into the screw on the bottom, unscrew that, turns off. Now you can safely plug in your battery. Now, if you plug in your wrench, turn it clockwise, tighten. That's clockwise, right? Yeah. Righty, tighty, lefty, loosey. So now, we're going to want our radio, which you should have already bound to the receiver in here. I'm going to grab my FSI 6 here. And basically, what we want to do is bring the stick all the way down. And what we're doing here is we are making sure that we have the arm sitting nice and flat to the floor, basically in the downward position. So I am going to pull the servo out a little bit, stick that on. We'll see that's a little bit too high. Turn it one more tooth. There's 25 teeth on the spine, so there's like a lot of adjustability here. I want to get it kind of close. I think that first one I did might actually be about as close as I'm going to get it. Alrighty. Next, in our radio, we are going to go in the FSI 6, OK, down to function setup, OK, down to endpoints, OK, OK again to get to channel 3 because that's this channel. So now we are just going to hit up and down to try and get it so that the arm is nice and flat to the table. So you can see if I push down, it basically is making that percentage go smaller because we're going further away from the maximum. If we push up, we are making that percentage bigger to go closer to the maximum. You can go a bit over 100%. I like to get it to the point where basically this is like returning to touching the table, but not powered too hard into the table. I might back off a little bit in this case. Alright, now we hold cancel to confirm on the FSI 6 because they set it up stupidly. One other thing is I'm going to set the servo arm up just a tiny bit and then hold the black button on my receiver to set this as the failsafe position until it blinks, and then you let go and that's the failsafe position. So now if I turn off my radio, it should return to that slightly up position, just to make it so that the failsafe position doesn't drive it like through the floor or through the robot's frame. Alrighty, don't need the transmitter for another little while. We can power off the robot. And unplug the battery for now. Alrighty. Next up, we want to install the servo properly. So for that, we are going to need a few parts. First, we are going to need the servo retaining plate, and we're going to need the servo arm support. So I forgot to grab those. Let me go grab that real quick. Alrighty. Carbon fiber arm retainer, and we've got the arm pivot support, which is TPU. Yours might be a different color. I just have a bunch of white ones at the moment. So first thing we're gonna do, grab another handy dandy shoulder bolt. You're gonna shove it all the way through this guy. It should be snug but not impossible to turn. And we are going to shove it all the way through this guy and then use our screwdriver to tighten this one up. Doesn't matter if it spins for now. It should be threading into the actual M3 thread on the servo spline. Alrighty. Next, make sure this is tilted down. And we are going to slot the servo back into place. Might have to undo the cable. And then we can redo it. I ordered some more servos that have a longer cable, so this is much trickier than it probably will be in the future. There we go. Then, stick our little servo retaining plate on here. And we will grab a couple of our Torx T10 number 6 plastites, these black flatheads. We're gonna zap that guy into place with the lowest torque setting on our driver. Perfect. So servo's not going to be going anywhere that way. Now, while we're here, we've got our motor mount plates here. So we've got our left and our right, because the robot is facing the wrong direction for that to actually make sense. And we're just going to do these front two on each, again with the same screws. Make sure they line up with the holes nicely. And again, your lowest torque setting for these. Perfect. Now our wheels are on the ground and the rest of the body should be off the ground except for little hinged forks. Also probably have to readjust this a bit, but it's good for now. Now we can flip the whole robot over. And we should see the holes vaguely lining up with those 4 positions there. 4 more of the same screw. These ones, because it's going into TPU, they don't really thread that well. So they're kind of just little extra insurance. Just go just until they kind of get within that hole. Probably won't hear the clutch kick in on your driver because it's too soft of material, but screws do their job just as well anyway. Alrighty, we've got our servo fully installed, we've got our drive set up, everything is pretty much good to go. Now we are just missing battery and zip tie, and pretty much got a ready to run robot other than the lid. Real quick, before I button this up, I'm going to show the assembly for the anti-horizontal arm. So I have a third fork here, which may or may not be included in your kit. I forget if I decided I was going to include those as standard or not yet. So this is much like the other arm, except for you're going to be using the M3 flathead black screws instead of shoulder bolts on this one. So just stick your PEM flush nuts in here. And then the 2mm driver and your 3 little black flatheads. Just gonna thin up. Look nice. There we go. Is it there? One more. Ready? So those screws are nice and tight on there. And then you would do the same process as this guy where you put the steel arm in, you put one more screw in here, and then your pivot support and everything, set it up so that your zero position's about there, yada yada yada, pretty much the same as before. For the wedge, also probably doesn't really need me to show you anything other than there should be a beveled side and a not beveled side. The not beveled side is the outside. And then your mounts just kind of slap on there. And you're going to want to make sure that the holes line up nicely. Get your screws. Can help to get like one or two of them where you can really see it going in properly. These ones, again, it's going into soft TPU, so you might not hear your clutch kick in. Just try not to over tighten too much. Oh yeah, and dovetails on the top surface, of course. And then, you know, pretend I did all 12. So I'm trying to save time a little bit here since the video doesn't take forever. Yep, and then you just do the remaining screws like so, and you'd have a nice little wedge attachment. Okay, so we got anti-horizontal arm, got the wedge, we've got everything else. Let's get a zip tie for our battery. So for our battery, we're going to basically, I would recommend you put some electrical tape over these connections, by the way. Slap the battery there with the balance lead facing this way. This is not going to be done very tight. You're basically just going to kind of keep these guys together with a loop. That is plenty, maybe even tighter than it needed to be. In fact, I think I accidentally zipped the motor wires offside, but whatever. Still fits in there anyway. Grab some flush cutters, clip that off. Battery cable can plug in right there. And now, all we have to do is grab the lid, put in 15 of these guys. So let me do that, just for the sake of completion. So you're going to want to make sure that your wires aren't stacked on top of anywhere that they could get horribly pinched. This little balance plug can get tucked back there. Countersunk side facing up. And you should have the cutout for the arm on the correct side. It's a little off center. Start up here. I like to do the one in the middle of the back next. And then we can just go around and do all the rest. Now if you're gonna leave out any screws, don't leave out these ones in the back because they help secure the motors in place. If you have to leave out two screws for some weird reason, you lost a couple, this hole and this hole are definitely the two to miss. I even might recommend, if you're fighting a vertical spinner, that you leave those out because it makes it less likely that you just crack right here if the vertical spinner catches this little wing here. Those wings just make it so that the bot doesn't get stuck in this position and flops back onto its wheels if it gets on its side more easily. Perfect. Now, should be able to just turn this bad boy on, drive it around and lift stuff. How about that? You've now built your very first SSP kit. If you're gonna drive this in an apartment, like I am, one thing that can help is add some tape, or even like a piece of plastic and some tape to under all of the pointy bits, and just raise the lifting arm a little bit. And that should help you not get caught in every floor seam like I just did. But overall, you've got a completed robot, ready to go.